Hey, 7th grade, we're going to go ahead and get started on the next section, which is also about volume, but this time we're going to be talking about volume of pyramids and cones. I put the heading, I had a little bit of space underneath the last set of notes that we did, and I also put the date off in today's margin, or today's date off in the margin. Woo. If you have not printed the cutouts, I do have them posted on the Google Classroom. Please pause the video and go do that before you continue. Alright, so I need some space. I'm going to pop up over here. And before I get started on any actual problems, I'm going to write out the formula for the volume of a pyramid. And this is going to work for any pyramid, but we're mainly going to be dealing with square pyramids. But the formula that we're going to use is volume equals 1/3 area of the base times the height. You'll remember when we did area of rectangular prisms, it was area of the base times the height. With pyramids, it's going to be 1/3 the base times the height. So it kind of relates back to it. It's a little bit different. It just has that extra fraction in the beginning of it. That is the only extra step for this one. So I'm going to go ahead and write a number 1, and this is where we're going to grab our first cutout. Should look something like this. So I'm going to write the letter A, and I'm going to pause for a moment and glue that in. Please do the same. Alright, so I have mine glued in, and there's actually something I'm going to have you add to this drawing before we get started. And this here is what we call the slant height, and that's actually something I want to do in the next example. So I'm going to have you add in a dotted line right here, and this is going to be the actual height of the pyramid, and we'll just label that as 4.5 meters, just to make life simple. Alright, so the first thing I'm going to do is rewrite my formula, because that's what I do every time. 1/3 area of the base times the height. Let me move this down a little bit. There we go. Alright, so the area of my base happens to be a square. So area of a square is going to be the length times the width. So volume is going to equal 1/3 length times width. Well, they're both the same. It's 4 times 4. Okay, and the height, I told you to write it in as 4.5. Alright, so then what we're going to do is volume equals 1/3 times 16 times 4.5. And I don't have my calculator again. Hold on, I'll be right back. Alright, I'm back. Actually, instead of using a calculator, I'm going to convert this into 1/3. I'm going to write this as 16/1. I'm just turning it into a fraction. And this would be 4 1/2, so it would be 9 halves. So, yeah, I'm just going to do it this way. So I can actually cross-cancel a lot of stuff in here. This would become a 1, that would be a 3. This would become, divide 2, it's 1, and oh, actually this comes out nice and even. So I get 24 meters, that's the unit that we're dealing with, and cubed, because it is volume. Actually, that way worked out pretty nicely. Perfect. Alright, let's try the next one. Now this one's going to be a little bit different because actually this past one was originally like this until I had you put in the 4.5, but this one is going to be a little bit different because I'm not going to tell you what the height is, but we are going to figure it out. So let's go ahead. I'm going to pause and glue this in. Okay, so I have mine glued in, and kind of like how I mentioned in the last one, you have what is the actual, you have the actual height of the pyramid, but then you also have something called the slant height. All right, this is kind of like the height of one of your triangles, and this is the height going straight from the center all the way up to this main point. And remember what we call this point? We call this the apex. So the actual height of your pyramid, the one you use to calculate volume, goes from the very center to the apex. All right, so in this particular problem, we aren't given that. We don't know what the height is. But we can figure it out, because if you notice, the height along with this slant height of 13 centimeters makes a right triangle. What do we know about right triangle? We can use the Pythagorean theorem to figure out the other measurements. So 13 here is going to act as my hypotenuse. How big is this one? Well, remember, I said the height goes from the very center to the apex. So if this is the center, this measurement is halfway. So if this whole thing is 10 centimeters, halfway must be 5 centimeters. All right, so H is like one of the legs, 5 centimeters is like the other leg, and 13 centimeters is like the hypotenuse. So when we do Pythag, remember it's a squared plus b squared equals c squared. A and b are both legs, and c is the hypotenuse. Okay, so what we're going to do is we're going to rewrite a squared as h squared, because they're giving us h as our variable here. We're going to rewrite b squared as 5 squared, so that would be 25. And we're going to rewrite c squared as 13 squared, which would be 169. Okay, from there we're going to subtract 25 from both sides. We get h squared equals 144. And from there we would take the square root. We don't even need a calculator for this one, because h is going to equal 12. So we now know that this measurement here, h, is 12 centimeters. Now we can go ahead and calculate volume, and I'm actually going to pop up to the top of my next page. Alright, so I'm going to rewrite my formula. Volume equals 1/3 area of the base times the height. I'm just going to look at it real quick. Down here you have a square pyramid again, so your base is a square. So we're going to find the area of the base by doing length times width. So volume is going to equal 1/3 area of the base, which is 10, excuse me, times 10. And then we found that the actual height going from the center point up to the apex was 12 centimeters. So volume is going to equal 1/3 times 100 times 12. And what I'm actually going to do, this is kind of like what I do when I find the area of a triangle. I always have, when I have a fraction out front, I can apply it to either of my numbers first and then multiply by the other one. So what I'm going to do is I'm actually going to take this 1/3 and multiply by the 12 first, and then take that and multiply by 100. Because I know that if I do 1/3 times 12, I get 4. And then it's very easy to do 4 times 100, because that's 400. And we were dealing with centimeters, so this would be centimeters cubed. So that is how you do volume of a square pyramid. Next, what we're going to look at is the volume of a cone. And volume of a cone is actually going to work the exact same way. It's still going to be, the volume is 1/3 area of the base times the height. Except this time, your base is going to be a circle. That is the only difference. We will still use the same formula. It's very much related to the volume of a cylinder. Volume of a cylinder was still area of the base times the height. It's just the area of your base happened to be a circle. So, you should have a cutout that looks like this. Oops. That looks like this. So I'm going to put a number 2. I'm going to put an A. And I'm going to go ahead and glue that guy in. Alright, so I have mine glued in. And I'm just going to work off to the side here. So I'm going to rewrite my formula for volume. Volume is 1/3 area of the base times the height. So let's recall real quick how to find the area of a circle. Remember, area of a circle is going to be pi times the radius squared. And we're going to use, for pi, 3.14. So for this one, you probably are going to want your calculator close by. Alright, so volume is going to equal 1/3 area of the base, which will be 3.14 times 4, that's the radius, squared, times the height, which is 10. So volume is going to equal 1/3. I'm going to clean up this inside piece here. I'm just going to go ahead and grab my calculator and do 3.14 times 16, because that's 4 squared. And I get 50.24. That's times 10. So volume is going to equal, I'm going to multiply these first, 1/3 times 502.4. So I'll go ahead and do that. And I get, I'm just going to round to the nearest tenth. Volume equals 167.5 meters cubed. So that is the volume of that cone. All right? Basically, what you have to do is find the pieces of your formula and plug them in, and then just let your calculator do the work from there. The next one we're going to do, and this is going to be letter B, is going to be like a work backwards kind of problem. This should be your last cutout, and actually I'm going to put it right there, and I'll put B here. There we go. So go ahead and glue this in. This is going to be the last one that we do for this set of notes. Alright, so I have mine glued in. I'm going to go ahead and read it, and then we will come up with a way to solve this one. So it says, an ice cream shop owner designs a new ice cream cone. He wants the volume to be about 240 centimeters cubed. The cone is 14 centimeters tall. What is its radius? Okay, so we know that I'm going to kind of do this in almost like 2 columns because I don't have a ton of room here. Volume is going to be 1/3 area of the base times the height. So what we're going to do is we're going to plug in the pieces that we know and work backwards from there. So the volume is going to be 240 centimeters cubed. I'm going to rewrite 1/3 because that's just part of the formula. Area of the base we don't know yet, but we do know the height. That's going to be 14. Okay, so what I'm going to do from here, I'm going to do this in 2 parts. The first thing I'm going to do, since this is being multiplied by 14, I'm going to divide by 14 on both sides. Okay, so I'm going to grab my calculator and go ahead and do that. Alright, so I've got 240 divided by 14. I've got about 17.1. So I have 17.1 equals 1/3 times the area of the base. So since I want to get B by itself, because this is the area of the base that's going to help me figure out the radius, since 1/3 is being multiplied by the area of the base, I'm going to divide by 1/3. But remember, if you're dividing by 1/3, that's the same thing as multiplying by 3. So multiply each side by 3. So I'm going to take this number times 3. I get 51.4 equals area of the base. But I don't want the area of the base because remember, what does this B actually stand for? It actually stands for, whoops, 0.4. It actually stands for pi r squared because that is the area of my base. It just happens to be a circle. So I'm going to divide both sides here by pi, which is really 3.14. So take this number, divide 3.114. All right, and I'm going to round to the nearest tenth. I get 16.4 equals r squared. I'm going to take the square root of both sides. And give me a second while I do this on my calculator. Square root, whoops, sorry, 16.4 square root. So I get 4, around to the nearest hundredth, so I have something. So for r, I'm getting approximately 4.05 centimeters. So that is about how tall, or sorry, no, we know how tall. That is about what the radius of this cone will be. Okay, so whatever pieces you're given in the word problem, you're going to take those, plug in what you know, and work backwards from there. Alright, so what you're going to do now is you're going to hop on over to IXL and practice these skills there.